In this video, I'm going to go over how to find domains algebraically. And what we're going to be looking at is rational functions, we're going to be looking at radical functions, and we're going to be looking at a combination of the two. So my first case scenario here is I have some rational functions. So I have y equals 1 over x minus 2. So what we want to remember is that the denominator, if we divide by 0, it's going to be undefined. So with rational functions, it's either going to be a whole or it's going to be a vertical asymptote. So what we want to do is we want to make sure that we check the denominator here. So I can see here that if I have x equal 2, x equal 2 would make this undefined, sorry. So that means that x equal 2 cannot be part of our domain. So in our domain, x cannot equal 2. So that means in interval notation, I'm going to write this out as negative infinity to 2 union positive 2 to infinity. Okay? So that would be our domain for the first one. Okay, next we have 8 divided by 3x plus 9. So same thing here. I don't want to divide by 0. So what I'm going to do is I'm going to set the denominator equal to 0. So I'm going to set 3x plus 9 equals 0. And then I would get x equal negative 3. So that means negative 3 cannot be part of our domain because it makes that function undefined. So when we write out our domain, we cannot include the negative 3. So in this case here, x cannot equal negative 3 as our part of our domain. So we're going to go negative infinity to negative 3 union negative 3 to positive infinity for our domain. All right. All right. Next case scenario, I have a rational function and I have a quadratic in the denominator. All right, so what I want to do is I want to factor that. So I would get 6x divided by, and it looks like two numbers multiplied together give us 12, but when I add them, I get 7. So that would be x plus 4 times x plus 3. So that means that x equal negative 4 and x equal negative 3 would make our would make 0 in the denominator, so it would make the function undefined. So that means that these values cannot be part of our domain. All right, so we can't have these in the domain. So that means our domain in this case here would be negative infinity to negative 4 union negative 4 to negative 3 union negative 3 to positive infinity. All right, so that's how we would deal with rational functions. And let's look at radical functions next. Okay, so in our next case scenario, we're going to be finding the domain algebraically, but we're going to be dealing with radical functions now. So we want to remember now with radical functions, if we have an even power, what's inside the radical can't be less than 0. All right, so our first case here, we have f of x is equal to the square root of x minus 7. So square root is 2. So this is an even power. So that means the values that we need for our domain, x minus 7, would have to be greater than or equal to 0. So 0 is okay with this because we can take the square root of 0. All right, so we're going to solve for x. So x would have to be greater than or equal to 7. So when we write this out in interval notation, we're going to start at 7. And I like to call this a hard bracket, meaning we're including 7. And then we're going to all the values greater than equal to 7. So we're going to positive infinity. All right. Okay, so in the next problem, we have the square root of x squared minus 4. So again, what we want to solve is this inequality, x squared minus 4 has to be greater than or equal to 0. And in this case here, I like to get the critical numbers. So the critical numbers where x squared minus 4 would equal 0, and I like to do a number line test on these. So if I take x squared minus 4 and I factor, and it's a difference of squares, I get x minus 2 times x plus 2. So now the critical numbers are going to be where this equals 0. All right, so we're not going to solve the inequality yet. So we can see that at x equal plus or minus 2, I have critical numbers. So what I'm going to do is I'm going to set up a number line test. So that means if I have -2 and +2, I'm going to pick test points and see which of the values are greater than or equal to 0. So in this case here, if I plug in a -3 into x minus 2 times x plus 2, I would get a negative times a negative, so this would be positive. So all these values would be positive. If I plug in a test point between -2 and 2, if I plugged in 0, I would get a negative result. And if I plugged in a value bigger than 2, I would get a positive times a positive. So that would be positive. So that means just looking at our number line test here, my answer in interval notation would be that x squared minus 4 greater than or equal 0 would be, the domain would be from -infinity to -2. We can include -2 because it can't equal 0. Union +2 to +infinity. So that would be our domain for the second one. Okay? Okay, and our third problem here, you can see it's not the square root now, it's the cube root. Well, the cube root, being less than 0, is okay with the cube root. So since that, if that's negative in there, we can still take the cube root of that, which is different from an even power. So in this case here, the domain would be all reals, -infinity to +infinity. All right, so then on our next one here, we have a quadratic inside the radical. So this is an even power, so we have to make sure that x squared minus x minus 12 is greater than or equal to 0 for our domain values. So I'm going to factor this, and it looks like this factors to x minus 4 times x plus 3 greater than or equal to 0. So that means my critical values would be x equal 4 and x equal -3. Those would be the values that would equal 0. So that's what I'm going to set up on my number line. So I have a -3, and I'm going to put a 4 over here. So if I have a value less than -3, that would give me a negative times a negative. So that would be a negative times a negative would be positive. If I have a value between -3 and 4, so let's say we plug in 0, that would give me a negative times a positive, so that would be negative. If I have a value bigger than 4, if I plugged in, let's say 5, I would get a positive times a positive. So that means that in interval notation, my domain here, so this is good and this is good. So that means our domain would be from -infinity to -3. I'm going to include -3 because we can't take the square root of 0. Union -4 to +infinity. Okay? All right, so then in our next video, what we're going to do is we're going to combine both of them, radical and rational functions. Okay, in this last set of examples, we're going to find the domain algebraically, but we're going to use a combination of radicals and rational functions. So what changes in this? Well, I have a radical in the denominator, so I know that I can't divide by 0, but also what's inside the radical has to be greater than 0. So what I'm going to do is I'm going to adjust what I'm solving for the inequality now to 2x minus 10 has to just be greater than 0 because I cannot include 0 in this case here. Okay, so when we solve this, we would get 2x is greater than 10, so x has to be greater than 5. So our answer in interval notation would be soft bracket 5 to positive infinity. Okay? Our next example, we have the radical in the numerator, and we have a 2x plus 7 in the denominator. So let's check the denominator first. That cannot equal 0. So 2x plus 7, when it does equal 0, x would equal negative 7 halves. That means negative 7 halves cannot be part of our domain. Also, x squared minus 100, that has to be greater than or equal to 0 in the numerator. So I'm going to solve that. X squared minus 100 has to be greater than or equal to 0. So I'd get x minus 10 times x plus 10 is greater than or equal to 0. So that means with the number line test, I'd have negative 10 and positive 10. So if I plugged in negative 11 as a test point, I would get a negative times a negative, so that would be positive. If I plugged in 0 as a test point, I'd get a negative times a positive, so that's negative. And if I plugged in positive 11 as a test point, I would also get positive here. So that means that my solution in this case here, so negative 7.5 cannot be part, negative 7 halves can't be part of the domain, but we can see here that negative infinity to negative 10 is part of my domain, and positive 10 to positive infinity, and the negative 7 halves would fall within this range here, which I'm not going to include in that domain. So the answer in this case here would be negative infinity to negative 10, and I can include that union positive 10 to positive infinity. Okay? All right, so now let's take a look at the last problem. Okay, so for our last example, we have the square root of 7x squared minus 31x minus 20, all divided by 7x squared plus 9x. So what I'm going to do is I'm going to factor an x out of the denominator, so I would get x times 7x plus 9. So that means that x cannot equal 0, or x cannot equal negative 9/7 as part of my domain. Okay? Now up top, my radical, that's a square root, so I'm going to factor what's inside there, and I would get 7x plus 4 times x minus 5. Okay? So that means that with my radical in the numerator, that 7x plus 4 times x minus 5 has to be greater than or equal to 0. So that means, again, my critical numbers are negative 4/7 and x equal 5. Okay, those would be the values that do equal 0 when we plug in. So good test points. Well, let's pick negative 1 as a test point to the left of negative 4/7. That would give me a negative times a negative, or positive. A good test point between negative 4/7 and 5 would be 0. Okay. And, well, we already know that x can't be equal to 0, so let's choose 1 instead. So if I plug in 1, I would get a positive times a negative. I would get negative. Okay. And then choose a point bigger than 5. So let's choose 6. So I would get a positive times a positive. So this is positive. So when I write out my solution, I can see that x can't equal 0, but That's okay with this part because my numerator's values that I need would be negative at that point, so that's okay. Um, X cannot equal negative 9/7. Now, negative 9/7 does fall within a part that I need for the numerator. So what I'm going to do is I'm going to, when I write out my solution here, so my solution would be negative infinity to negative 9/7. Now I can't include negative 9/7 because it makes the denominator undefined. So I'm going to union that with negative 9/7 to negative 4/7. Negative 4/7 would get a hard bracket because that's okay. And then the final part that I have to combine with this would be from 5 to infinity, and we would have our domain here. So that one was more difficult than the other ones. Okay, I hope this video helped you examining domains algebraically. Please like and subscribe, and thanks for watching.